Hello students, this is the continuation of problem 4, and it's an example of trying to find the forces against charge 3. When we have charge 1 and charge 2, we do have the distance between charge 1 and charge 3, 10 centimeters. We have one for charge 1 and charge 2, 8 centimeters, but we do not have between charge 3 and charge 2, which is the one we're looking for. So in order to do that, we're going to have to do some trig analysis, which I'll get to in a minute. And just to remind you, we're going to be solving for the total forces against charge 3. So we got to find the force between charge 1 and 3 and the force between charge 2 and 3. Okay, so find the total forces on Q3. So I'm starting to list my knowns. So you know the charges, quantities. Charge 1 was plus 0.71 times 10 to the minus 6. Charge 2, minus 0.76 times 10 to the minus 6. Charge 3 is a plus 1 times 10 to the minus 6. Your K constant, 8.99 times 10 to the 9. And my equation, the total force on charge 3 is going to be the force between charges 1 and 3 and the forces between 2 and 3. So the first one I'm going to find is the force between 1 and 3. If you look back at the diagram I drew, you have the Q3, you have the quantity of Q1, you actually have the distance, so you have everything that you need to solve for the force for between 1 and 3. So at this point, it's just, here's the equation of finding the force between the two charges 1 and 3. You're going to have the K constant, the actual charge of 1, the charge of 3, and then the distance between 1 and 3 squared. So I always write my numbers out. Here's my things written out. And remember, the 10 centimeters I put into scientific notation so I can put it right into the calculator. And I also need to square that, so I'm double starring that for you. So like before, I'm going to try to put this into the calculator. I guess you can move it over to right here. So if I have 8.99 EE9 times 0.71 EE negative 6 times 1 EE negative 6 equals. And then I'm going to divide by 10 centimeters squared equals. So I'm left with the number of 0.63829, which is what I wrote here. And so I have one of them. The next one is basically the same thing. We're going to find force between 2 and 3, but we need to figure out the distance. So I'm actually just going to go through a new one for you. So in order to do that, we have to do a little bit of trig. I'm just rewriting. So you're going to have an angle here. This is the distance we want. So if you remember from trig, the angle, this is the opposite side, this is my adjacent side, and this is my hypotenuse. And if you remember your SOHCAHTOA, the sine is the opposite over hypotenuse, the cosine is the adjacent over hypotenuse, and the tangent, TOA, is the opposite over the adjacent. Okay, so in order to get A, I have to find the tangent first. Since I have O and H, I'm going to pick my sine. So the sine of the angle is O over H, but I want the angle by itself, so basically you divide by sine. It becomes sine to the negative 1, which I call inverse sine, O over H. So if I plug this all in, we're going to have 8 centimeters over the 10 centimeters. In the calculator, it goes. So, if I have 8 centimeters divided by 10 centimeters, now you see the sine function here. Right above it in green is sine to the negative 1. So I'm hitting the second sine function, and I get my answer. So the angle is 53 0.1301 is as far as I'm going to go. Definitely make sure you keep 3 spaces here in all your calculations. Now we're not quite done. We need to find A now, the distance. So, since I have the angle now, I'm just going to pick the O